we have two parts of a question dealing with the graph of f of x equals the exponential function 1/8 to the x power. And you'll remember that for y equals 1/8 to the x, the graph is going to be decreasing through quadrants 1 and 2 with an horizontal asymptote at the x-axis. Its y-intercept will be 0, 1, and its a second point on the graph would be 1, 1/8. So 1/8 to the 0 is 1, and so 0, 1 is one of the points, and 1/8 to the 1 is 1/8. So 1, 1/8 is also a point on the graph. Now looking at g of x, we see that g of x is the same as f of x quantity minus 1. So the graph will take all of the y values in f of x and subtract 1 from them. This will result in moving the graph down 1 unit. And so instead of the horizontal asymptote being at the x-axis, or y equals 0, it will be at y equals -1. And 0, 0 will be moved down to the origin, and 1, 1/8 will be moved down to 1, -7/8. We can confirm that because g of 0 would be 1/8 to the 0 subtract 1, which would be 1 minus 1, or 0. So g of 0 is 0. And g of 1 would be 1/8 to the 1 minus 1, which would be 1/8 minus 8/8, which would be -7/8. In part B, h of x is actually f of the quantity x minus 1. So x has been replaced by x minus 1 in y equals f of x. And this is going to mean the graph goes 1 unit to the right. And so this time the x-axis continues to be the horizontal asymptote, but the graph is moved to the right. And what was 0, 1 is now 1, 1, and what was 1, 1/8 is now 2, 1/8. We can verify that g of 1 is 1. I'm sorry, this isn't g, this is h. H of 1 should be 1. It would be 1/8 to the 1 minus 1, which is 1/8 to the 0, which is 1. And h of 2 is 1/8 to the 2 minus 1, which is 1/8 to the first, or 1/8. Now, we have another question to do in this video, and it is to compare and contrast the graphs of y equals 2 to the x, y equals the opposite of 2 to the x, y equals 2 to the opposite of x, and y equals the opposite of 2 to the opposite of x. This time the base is 2, so our basic function, t of x equals 2 to the x, is an increasing function through the first and second quadrants, going through 0, 1, and 1, 2. T of x equals the opposite of 2 to the x is, this is r of x is the opposite of 2 to the x, is the same as the opposite of the function t of x. So it's going to take y equals t of x, which is the first graph we've drawn, and it's going to reflect it over the line y equals 0, or the x-axis. And so the graph will now be a decreasing function through the third and the fourth quadrants, still going through the origin, not the origin, going through the point 0, negative 1, and the point 1, negative 2. Going across to u of x equals 2 to the opposite of x, we notice that this is the same as t to the opposite of x. So it's the same as taking the graph of y equals t of x and reflecting it across the y-axis. This interchanges the graph in the first and second quadrants. Zero, 1 is unchanged, but 1, 2 is now negative 1, 2. And lastly, S is the opposite of t of the opposite of x. And so if we want to think in terms of the function on the right, which is y equals t to the opposite of x, we will reflect this one over the x-axis, and when we do that, the curve will change from decreasing to increasing, but it will be in the third and fourth quadrants. So it'll be negative 1, negative 2, and 0, negative 1. Or we could start here and notice that the x has been replaced by the opposite of x, and so this g of, or s of x equals the opposite of 2 to the opposite of x could also be thought of as r to the opposite of x. So that would say that we could take the graph of r to the x and flip it over the y-axis. And when we did that, we would get an increasing graph through -1, -2, and 0, -1. Notice the last two graphs that we drew were identical. So you could arrive at the graph either by reflecting over the x-axis, then the y-axis, or the y-axis, then the x-axis. So these are both the graph of y equals s of x.